Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, a podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Our guest today is Tom McNamara, Vice President of C-Band Transition Management for Intelsat. Today we will discuss the accelerated rollout of 5G and the purpose of satellites in the C-band relocation effort. 5G cellular services hold the promise of connecting everything, everyone, everywhere. The transition will unleash massive amounts of bandwidth for new and innovative applications. To drive America's leadership in 5G, the FCC is accelerating the rollout by repurposing the C-band spectrum, which is thought to be optimal for 5G services. Intelsat is one of the satellite operators that has used the entire band and now has agreed to mobilize its operations to promptly relocate to a different portion of the band in support of the 5G rollout. To tackle this unprecedented and challenging transition plan, Intelsat has put together a team of more than 50 employees focused on this complex clearing initiative. The team is working to successfully and quickly transition current users while maintaining a high-quality, uninterrupted broadcast to more than 100 million American homes and businesses. Intelsat also plans to build and launch multiple new satellites to replace C-band capacity being transitioned to 5G cellular network services. With us today to shed some light on their C-band relocation plan is Tom McNamara. He is the Vice President of C-band Transition Management for Intelsat. Tom has over 20 years of experience as an operations executive. Tom, this seems like a big project you got your hands on, isn't it?
Oh, yeah. I like to call this the Hoover Dam project for the satellite industry. It is massive, but it's really exciting and interesting work.
Yeah, they say that the Hoover Dam will be, people will be able to see it in 1,000 years or something. So we see how long this one takes. So the real question is, for the project this massive, what motivated your company to move forward with the FCC's plan to accelerate the relocation of the C-band spectrum?
Sure. So in 2017 and 2018, the FCC began to inquire about what it would take to free up more mid-band spectrum, which is really important for the efficient and economic rollout of 5G networks. There is a lack of available mid-band spectrum, and so they began to target sharing the C-band that we use for our customers to deliver television programming, cable programming, and we saw it as a potential threat to our industry. And so as we began to look at it, we turned things on their head and said we could either fight this, and we're probably not going to win, or maybe we can go and make lemonade from lemons here. So we approached the FCC and said, we will volunteer to free the spectrum. We will do the work to free the spectrum if you'll allow us to sell the rights to it. That concept got debated for a couple of years, and after much debate, they did not adopt that exact plan, but they did offer C-band operators an incentive to clear the band quickly. And so we thought it through, considered it very carefully, and decided that if the clearing is going to happen anyway, we want to make sure that we are in control of the process to ensure an orderly clearing for our customers and preserve the industry. So we had a plan. We'd been working on an engineered solution and all the project planning for 2 years. So we believed we could get it done and achieve the acceleration date, so we decided to accept it and go forward.
We've done interviews with a lot of startups, and they always talk about innovation and flexibility and everything else. You're a fairly large company. This really displays a lot of flexibility on your part, doesn't it?
Sure. Yeah, I think most of this work is the work that we do regularly in the course of business. And so there's nothing earth-shattering here in terms of the individual technologies or tasks, but the totality of it, the scale of it is a bit daunting, but I think Intelsat is one of the few companies that could accomplish this. We have some of the best satellite technology experts in the industry and just a wealth of experience doing these activities. So we're well suited for the work.
So, Tom, do you believe or do you think that 5G is complementary or competitive to satellite?
Oh, we definitely see it as complementary to satellite. We think there's a big opportunity for satellite to play a part in the 5G ecosystem that's being built and to integrate satellite really into the larger telecommunications space to support a wide variety of the use cases that are being talked about for 5G. Satellite offers some really interesting advantages to complement the 5G mobile networks. We can cover virtually all of the inhabited Earth. We have no distance or topography or line of sight issues. We aren't impacted by natural disasters or human conflicts. So we are a reliable worldwide partner for 5G to support backhaul for their entire network or for a coverage area. So we think we're part of that ecosystem. The standards include satellite in them for the first time, the 3GPP standards, and we're excited about 5G and what kind of opportunities that creates for Intelsat.
I think both you and I, if we look at the last 15, 20 years, have had a lot of discussions with software developers and project managers, and they always talk about scope creep and scope of this and scope of that. And so can you describe the scope of the C-band relocation effort and discuss the challenges in making this transition a success?
Sure. So as I mentioned, C-band's used primarily in CONUS for media, content, distribution, contribution, and restoration. So basically all national TV programming that you see on your cable networks or broadcast networks is touching a satellite at some point in the project, in the process of being delivered to your house. So the FCC is repurposing 300 of the 500 megahertz in the C-band. So we need to move our customers out of that lower 300 megahertz and repack them into 40% of the space we had available to us before. So there's really four main pieces of work to be done to accomplish that. First of all, we have to build and launch 7 satellites, which is massive. The satellites take 2 to 2.5 years to build and launch. It costs upwards of $150 million a piece. So it's no small task there. Then we have to repack the customers into their new homes across the fleet, and then manage the impact on the downlink side. So we move a customer from one transponder to another. That could be as simple as a frequency change on the customer receive sites, or it could be something more involved, like going to a cable head end and having to build a new antenna so that they could receive the feed from its new location. They may not have an antenna that points at that location. So repack the customers and manage the ground impact. We also have to consolidate our telemetry command and control antennas. These are the antennas that we use to fly satellites and to collect information about what's going on the satellite. Critical infrastructure for us. However, some of those signals are currently using frequencies in that lower 300 megahertz. So we need to pull these antennas as remotely as possible to get them out of the reach of likely 5G deployments for the next 10 years. And so we're really building out 2 teleports there with about 14 antenna. Finally, the final piece of the work is installing passband filters on 35,000 antennas throughout CONUS. So every receive antenna for C-band is going to get a passband filter that prevents it from receiving signals in the lower 300 megahertz so that the 5G signals don't interrupt that.
And the interrupt is the most important part, because you're doing this all while your customers are having uninterrupted service. And this is like driving your car and changing the oil as you're going down the road. It seems like quite a task.
It is. And, if you think about the television industry, they are extremely sensitive to any outage or any interruption. If you take a 3-second outage on a cable station, you're probably getting a call from your customer and getting yelled at, right? So it's a really interference sensitive group of customers. They like their signal to be perfect. They pay to make sure that their signals are resilient. So we need to be very careful about how we go about this so that we don't create any sort of disruption for them.
Heaven forbid someone miss their British Bake Off show, huh?
It's that secret ingredient. You got to get them all.
So what about your secret ingredients? What is unique with your expertise or experience or resources? What about your company, and what do you bring to bear on this complex development here?
Satellite is what we do. Intelsat is filled with expertise, some of the most highly talented satellite engineers in the world. Nothing we have to do here in and of itself is unfamiliar. Procure and launch satellites, check. Build antennas, check. Install ground equipment, check. Room services. We've done all of this before. The totality of the work and the speed at which it needs to be performed is really massive. But we've been planning this work for over 2 years and really worked through all of the kinks and the processes. We've built systems to support us. We've established partnerships with some of the finest field tech companies in the country, and we're ready to do the work. We have a high degree of confidence that we're going to be able to get this done on time. So those partners that we have about 40 internal employees working on this, and then hundreds of field techs. Literally hundreds of field techs throughout the country, because the antennas are everywhere and need to be, retuned or filtered. Yeah,
you talk about filtering. I think it was 35,000 antennas, and I wrote that number down, and I thought of this old antiquated expression called necessity is a mother invention. And so, are there any new technologies you've kind of whipped up in the back office there to help you in this relocation effort?
Yeah, so the filters, passband filters are nothing new, but we spent a lot of time in R&D over the last 2 years working with our manufacturing partners to develop a filter spec that is really efficient and can minimize the amount of guard band that we need and protect the customer's signal from the much more powerful 5G signals that are out there. So a lot of time on the passband filters, getting those just exactly where we wanted them to be. In addition, we're part of how we get to release 300 megahertz is by compressing customer signals. So we're implementing compression techniques for some of the content providers, such as advanced video coding or high efficiency video coding, HEVC, which requires work on the uplink antennas, and then new IRDs, new integrated receiver decoders at the receive sites to take advantage of the next generation of algorithms and encoding, and really reduce the amount of bandwidth that they consume afterwards. And so we're seeing some of our largest customers reduce the bandwidth required for them by half, which is saving them money in terms of what they pay for bandwidth each month, and also modernizing their plants and their distribution system. So it's a huge undertaking, and it's going to be a logistical challenge. But I think on the other side of this, we're going to be better off for it and better capable of existing in a world where we only have 40% of the C-band capacity that we had previously.
Let's go from capacity requirements to the ground station. So how big a role will your ground station strategy play in the relocation effort?
The ground stations are where the bulk of the uncertainty and the bulk of the work lie. So we're going to spend quite a bit of time at our stations and uncovering sort of different challenges at each site. We'll find antennas that are 30 years old and rotting. We'll find equipment that is outdated. We'll find that the antenna is mounted on the top of a steeple and we need a cherry picker. So really trying to get ahead of with outreach and virtual site assessments as much as we can before we get out to the site is a big part of our risk mitigation strategy to avoid running into just a scope creep and delays.
You know, Tom, thousands of people from all over the world have listened to this podcast. You go to Google and type in Constellations Podcast to get to our show notes page here. You can get transcripts for all 80 interviews. Also, you can sign up for free email notifications for future podcasts. We talk about topics like the one we're talking about today with Tom. So, Tom, how are you assuring high quality of service and minimizing the impact on customers during this transition? It seemed to be some burps and maybe some blackouts somewhere, huh?
Well, for each customer transition, we provide a dual illumination period, which is an alternate carrier for their service, for them to, at the same time, maintain their old signal on their old location with their new signal on the new location. That really allows the customer a chance to tune the service and get it just right, to peak the carrier and make sure they're exactly where they wanted to be, and then they begin migrating their customers over. This helps the customer throttle the process and ensures that all the receive sites are safely migrated before they shut off the old signal. So that's most of our services that are in scope for this are not managed services. Where we do managed services, there's a more of a QoS hands-on approach, but typically these are transport-only services, and the customer maintains the video quality, but we allow them to have extra transport so that they can get the service right and minimize any disruption or interruption of service.
Tom, I imagine you have a deadline for this. So how long will it take for the C-band relocation effort to be completed? There's
two key dates in the order. December 5th, 2021, we need to have 120 megahertz cleared on each of the satellites over CONUS, and to have filters installed on all of the receive antennas in 46 of the top 50 partial economic areas in CONUS. So that will allow 5G to be deployed in those top 46 markets starting at the end of next year. Then 2 years later, we need to have all the full 300 megahertz cleared and all antennas and CONUS filtered. Plus the satellites will be launched by then, and the TT&C sites, the telemetry and command sites will be consolidated by then.
And compensation for losing the spectrum, you mentioned that at the top of the interview here. Your company will receive billions of dollars from 5G bidders as incentive payments for relocation costs. So how will those funds be used?
Well, obviously, my main focus right now is doing everything I can to make sure we capture those billions of dollars and to ensure that we have a smooth transition for our customers and American TV viewers. But we have an entire team building out our business plan right now, and I'm sure they'll be anxious to share it in the coming months with the public. What I can say is that the satellite industry, in our view, is undergoing a massive transformation right now. This C-band initiative provides us the capital to adapt to those changes and expand our offerings to meet the needs of the new economy. So, consumers are using more and more bits. We sell bits. So we see this as a big opportunity for us, and we're excited about it.
Earlier, you talked about building satellites and how much they cost. And I would imagine these new satellites will be used to replace C-band capacity being transitioned to 5G. Can you tell us a little bit more about these satellites?
Sure. The satellites, we have 7 satellites being purchased. They are really, the purpose of the satellites is to extend the life of the C-band at those orbital locations. So where before we had less than fully utilized satellites in place, we were looking to consolidate to fewer locations with the full 500 megahertz. However, giving up the 300 megahertz forces us to spread that load over all of our orbital locations and reinvest and maintain satellites in each of those spots. So over the next 3 years, we'll be launching 7 satellites into orbit and replacing the existing assets that are there to extend the overall life.
Yeah. When you get a new car, you got to do something with the old one. So what's going to happen to the satellites that are going to be replaced?
Some will be retired at their end of life. They're approaching end of life right now, and they will be deorbited. Others may be repurposed for the remaining useful lives, but we'll have to see what those applications might be. Given the practical constraint that most of the receive sites don't have technical capability or like physical space to add new antennas, you can't just migrate content services or cable services to another location, to non-penetrated orbital locations. So really the only thing that's feasible for us is to extend the life of those satellites and keep the orbital locations there available so that if an antenna is pointed at an orbital location, there'll be a satellite guaranteed there for the next 15 or 20 years.
Tom, if I look at the last 10 interviews I've done, I probably asked this question more than any is how many satellites do you project in the next 4 years or 5 years? All kinds of numbers all over the place. And I know there's going to be a whole lot. And inevitably the topic of interference comes in. And so how are you addressing this issue of potential interference issues between satellites and 5G?
Well, we worked really hard on the filter and on the specification. We drove the technical specification with the FCC to ensure that they adopted a filter plus guard band approach to manage interference and to ensure that 5G didn't knock out satellite signals. So the standard that the FCC ended up adopting was a bit different than what we came up with and suggested. And so we're in the process right now of we are part of a working group formed by the FCC to deal with interference issues, how we will detect it, what processes we use to figure out what the source of the interference is, should it occur, and ways to remediate it if it happens. And so I think there's a work in progress there. We did a lot of good design work up front, and we're confident that those designs are going to work, but we also want to have a process in place for when interference inevitably happens due to either overpowering a base station or pointing it incorrectly. So we want to make sure that we're sure we know how we're going to approach it when the instance arises so that our customers are safe and the services continue. It's really important to get this right to continue the ecosystem and ensure that our industry is vibrant for years to come.
It's time for the crystal ball question. So get serious and get out your crystal ball and just maybe project out in 5 years from now and see what role is 5G and satellite going to be playing in the industry.
I think there's enormous opportunity for satellite in the industry over the next 5 years. The movement towards 5G is, and our standards are software-defined satellites and some of the other innovations that are coming along really open doors for us to converge with 5G and create new marketplace. Mobile network operators are going to be able to complement their 5G services with satellite connectivity to offload their scale and their terrestrial networks as needed seamlessly, interoperably with the satellite. So we think that there's a lot of room for us to fit right into that ecosystem, and the sky's the limit for us.
When the listener to this podcast thinks about, 100 million American homes and thousands of antennas and satellites, it gets kind of confusing. And I would just like to thank you for bringing clarity to this whole topic of 5G and the whole satellite in the C-band. It makes things a whole lot easier for me to understand. I hope it brings clarity to this complex topic for our listeners as well. I would like to thank our guest, Tom McNamara, who is Vice President Program Management for Intelsat.
Thanks very much, John. Thanks for having me.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.